Good morning, everyone. Before we start the lesson, we prepare an energizer, which is to guess the gibberish. So, how to play it? First, read the random words that will appear on your screen. The second is to speak aloud until you guess the right words based on the category. And the last is to answer before the time runs out. The answer should be taken on a piece of paper and written down. To check on your own paper and be true to the answer. And good luck! How many correct answers did you get? Let's now proceed with the lesson we prepared for you. For today's topic, we will be discussing models of the universe. Greek astronomy to Kepler.
Tycho Brahe, Danish astronomers whose work in developing astronomical instruments and in measuring and fixing the position of stars paved the way for future discoveries. It refers to Danish astronomer Tycho Brahe made the most accurate celestial observation of his time and challenged the prevailing belief in how the universe was organized. Tycho Brahe established a theoretical model of the universe known to us as the iconic model or Tycho Brahe model of the universe. It means the Earth is at the center of the universe, the Sun revolves around the Earth, and all other planets revolve around the Sun. Next is the iconic model. The Tychonic model is a theoretical model of universe that hypothesizes that Earth is center of universe. The sun, moon, and stars revolve around the Earth, and all other planets within our solar system revolve around the sun. That's why this model is also referred to as the geoheliocentric model of the universe, simply because it inherits the combination of both. In other words, Tycho's model retains the ancient Aristotelian view that Earth is the center of the universe, where the sun and the moon revolve around the Earth. On the other hand, retains the modern concept of the Copernican view that all other planets within our solar system revolve around the sun. This theoretical model of the universe was proposed by a Danish astronomer Tycho Brahe around the 1570s.
Johannes Kepler. So, si Johannes Kepler ay isang German astronomer, not just an astronomer but also a mathematician, philosopher, and music writer. He is best known for his laws about planetary motion, such as law of ellipsis, law of equals area, and law of harmony.
The law of ellipse, which describes how planets in our solar system orbit the sun in a path that it is not circular, but rather an oval shape called an ellipse. Ito ay isang araw kung saan sa gitna nito ay may dalawang foci na nagbibigay ng hugis ng ellipse. Para mas maintindihan, if you were to place two tacks inside the circle, one at each end of the triangle, then take a piece of string and stretch it around the tacks, you would create an ellipse. The two tacks represent the foci of the ellipse with the sun located at one of them. Isa pang paraan upang mas maunawaan ang law of ellipse is to look at a picture of the planet's orbit. This picture shows an oval-shaped orbit with the sun located at one of the foci. The point at which the planet is closest to the sun is called perihelion and occurs in January, while the point at which the planet is farthest from the sun is called aphelion and occurs in July. I hope you understand the law of ellipse. That's all. Thank you.
The second law, the law of equal areas. It describes the speed at which any given planet will move while orbiting the Sun. The speed at which any planet moves through space is constantly changing. A planet moves fastest when it is closest to the Sun and slowest when it is farthest from the Sun. Yet, if an imaginary line were drawn from the center of the planet to the center of the Sun, that line would sweep out the same area in equal periods of time. For instance, if an imaginary line were drawn from the Earth to the Sun, then the area swept out by the line in every 31-day month would be the same. This is depicted in the diagram below. As can be observed in the diagram, the areas formed when the Earth is closest to the Sun can be approximated as a wide but short triangle, whereas the areas formed when the Earth is farthest from the Sun can be approximated as a narrow but long triangle. These areas are the same size. Since the base of these triangles are shortest when the Earth is farthest from the Sun, the Earth would have to be moving slowly in order for this imaginary area to be the same size as when the Earth is closest to the Sun. The third law of planetary motion, harmonic law or law of period, states that the ratio of the squares of the periods d of any two planets revolving around the Sun is equal to the ratio of the cubes of their mean distance from the Sun. Sa madaling salita, the squares of the sidereal periods of the planets are directly proportional to the cubes of their mean distance from the Sun. It compares to the orbital period and radius of orbit of the planet to those other planets. It is the ratio of the squares of the periods to the cubes of their average distance from the Sun is the same for every one of the planets. Unlike the Kepler's first and second laws that describes the motion characteristic of a single planet, the third law makes a comparison between the motion characteristic of different planets, and the comparison of each planet can be shown in this illustration. So what does this illustration mean? Kepler's third law means how long a planet takes to go around the Sun, which is its period t, is related to its planet mean distance from the Sun. That is the square of the period divided by the cube of the mean distance is equal to constant, and for every planet, no matter what its period or distance, t squared over r cubed is the same number.
Now let's talk about how the season occurs. As the Earth spins on its axis, producing night and day, it also moves about the Sun in an elliptical orbit that requires about 365 and 1/4 days to complete. The Earth's spin axis is tilted with respect to its orbital plane. This is what causes the seasons. When the Earth's axis points toward the Sun, it is summer for that hemisphere. When the Earth's axis points away, winter can be expected. Since the tilt of the axis is 23.5 degrees, the North Pole never points directly at the Sun, but on the summer solstice, it points as close as it can, and on the winter solstice as far as it can. Midway between two times in spring and autumn, the spin axis of the Earth points 90 degrees away from the Sun. This means that on this date, day and night have about the same length, 12 hours each, more or less.
Why the Earth is tilted? The big thing that hit Earth is called Theia. It also blasted a big hole in the surface. Why the Earth is tilted? The Earth is tilted on its axis due to collision with a Mars-sized object during its formation, which transferred angular momentum and caused the Earth to rotate and become tilted. This tilt is responsible for the changing season on Earth, as different parts of the planet receive varying amounts of sunlight throughout the year.
The Earth's orientation. The Earth's orientation refers to its position and motion in space. It includes the Earth's rotation on its axis, its axial tilt relative to its orbit around the Sun, its precession, and its revolution around the Sun. These factors affect the amount of sunlight different parts of the Earth receive. which in turn affects the climate and weather patterns. The Earth's orientation also plays a role in the behavior of the Earth's magnetic field and the formation of auroras. Overall, the Earth's orientation is an important aspect of its overall functioning as a planet.
Did you know that Earth's shadow changes with seasons? The tilt of the Earth's axis affects the length of our shadows. During the summer, our location is tilted towards the sun, so our midday shadows are very short. During the winter, our location is tilted away from the sun, so our midday shadows are longer. Ang pagtilt ng Earth's axis ay nakakaapekto sa haba ng mga anino natin. Basically, mas maliit ang shadows natin kapag malapit tayo sa araw, at mas mahaba naman ang mga shadows natin kapag mas malayo tayo sa araw. Tuwing summer, mas malapit tayo sa araw kaya mas maliit ang shadows natin. Tuwing winter naman ay mas malayo tayo sa araw kaya mas mahaba ang mga shadows natin.
How do Greek astronomers define that the Earth is round? Lunar eclipse and constellation.
The difference between solar and lunar eclipse.
A solar eclipse happens when, at just the right moment, the moon passes between the sun and earth. So during a solar eclipse, the moon blocks the sun from view. Sometimes the moon only blocks part of the sun's light. This is called a partial solar eclipse. Other times, the moon blocks all of the sun's light. This is called a total solar eclipse. Lunar eclipse. During lunar eclipse, Earth's shadow obscures the moon. So lunar eclipse happens when the Earth is positioned precisely between the moon and the sun, and the Earth's shadow falls upon the surface of the moon, dimming it and sometimes turning the lunar surface a striking red over the course of a few hours. So, how Greeks know that the Earth is round? The Greeks used lunar eclipse as a way to know the Earth's shape or if the Earth is actually round. Empedocles and Anaxagoras once said, during a lunar eclipse, when the Earth is between the sun and the moon, they identified the shadow of the Earth and the moon. And one thing that they noticed and pointed out was that shadow is always round, regardless of where the Earth is in its rotation. So they concluded that the Earth must be round as well.
So, in constellations, how Greeks know that the Earth is round? According to Egyptians, stars or constellations do not change position with respect to one another over human lifetimes. This means that the ancient Egyptians believed that the positions of stars and constellations relative to each other remained fixed over long periods of time. They thought that the stars were eternal and unchanging, and that they were linked to the gods and the afterlife. The constellations were an integral part of their culture and worldview, with important religious, practical, and scientific implications. The Egyptians utilized diurnal parallax, an apparent change in the position of an object resulting from a change in position of the observer.
What is diurnal parallax?
To understand diurnal parallax, imagine holding a pen in front of your face and closing one eye. If you move your head slightly, the position of the pen appears to change relative to the background. This is because your line of sight to the pen has shifted. The same effect occurs when observing stars in the night sky from different positions on the Earth's surface. As the observer moves, the apparent position of the stars changes relative to each other, even though the stars themselves remain in the same position. However, Aristotle wrote that some stars are visible from Egypt are not visible from Europe. This would not be possible if Earth was flat
neither round.
So what does Aristotle mean here?
Aristotle observed that some stars were visible from Egypt but not from Europe and vice versa. This could only be possible if the Earth were not flat, because if it were, all stars would be visible from any point on its surface. This observation suggested that the Earth was curved, and that the line of sight of a star was affected by curvature of the planet. This insight was an important contribution to the understanding of the Earth's shape and helped establish the idea that it was a sphere.
And that's all for today's lesson. We hope that you learned something in this video. Goodbye and take care.